Okay, so this is a battery out of a Honda Jazz, 1.3 litre 4-cylinder motor, so it doesn't need a big battery to turn it over. But of course the car will have other electrics going on, interior lights, exterior lights, radios, air conditioning, that sort of thing. It also has a thermatic fan. So what's been happening is this battery is turning up flat in the morning. We charge it and it will certainly start the car. It seems to hold a charge, but then in the next morning it's flat again. So what I've got here is a couple of basic bits of kit. I've got a really good quality charger with some analytical capability, and I've got a battery load tester, which is capable of putting typical load on this battery to simulate starting an engine. So I'm going to use this equipment to see whether this battery is salvageable or whether it needs to be replaced. I really like this multi-stage battery charger. As you can see, it can analyze a battery, it can boost it, it can certainly charge it. It's a 20 amp charge capacity, so it's great for banks of batteries. But what I've been using it for today is to see whether a battery is worth keeping or whether it has to be chucked away. And so let me show you how that works. Now, as you can see, this battery has progressed nicely through the charging cycles, and it's now in a maintenance cycle. So sitting at, well, the charger's sitting at 13.8 volts and just feeding in an amp or maybe just a bit less. As you can see, it's in the maintenance cycle over here. What was happening previously is that the battery would charge here in the bulk phase or stage, drawing anything up to 20 amps and continuing to draw that amperage. This was happening 2 or 3 times, and my little charger was getting quite warm. So there was a lot of energy going into the battery. And I presume this was also happening in the car. Everything was running warm, too much current going into the battery. Something's not quite right. But now it seems to be okay. So I want to make sure that it's reliably okay. So what I'm going to do now is drain this battery down to the point where it would need charging again and see and observe its behavior on the next charge cycle. So I'm going to turn off the charger here and disconnect the clamps. And now I'm going to connect this load tester. So let's do that. Now this load tester is basically just a big resistive load here, and you might be able to see right in there, that's going to get really hot when I turn on this switch, and I'm going to watch the voltage, and initially you might be able to see the voltage is just hovering just underneath 14 volts, which is what we're observing on the charger. When I flick the switch, so I'll do that now, everything's safe. When I flick the switch, that voltage should drop down, but stay in the green zone, which it is doing. So a couple of seconds, and we expect it to return to a reasonably healthy voltage, obviously a bit lower than before, but yeah, and it's bounced back to over 13 volts, so that's good. So that's simulating one start. Let's try another one. Down into the green zone, holding there. That needle is not falling further, which indicates the battery is holding the charge. Sorry, holding the load, and then it's bouncing back up to just above 13 volts. And we would expect the engine to have started, and the battery would now be being charged by the car's electrics. Okay, great. Okay, so back on the charger now. I've carefully placed that load tester down. It was getting a bit warm, so that's safe. And I'm going to turn on the charger. Let's see what happens. Detecting 80% charge remaining. It's going through an analysis stage at the moment. checking to see the health of the battery. It'll do that just by pulsing power into the battery by raising the voltage up to, as you can see, up to 14 volts, seeing what the battery does, how much current it's drawing, raising the voltage just a little bit more, seeing how much current the battery's drawing. And if that current spirals out of control, the charger will shut down for safety reasons. Okay, now it's stabilized into a what's called a soft start, giving the battery a low low to medium amperage of about 8 amps. Now it's going into a bulk charge, basically allowing the battery to take whatever amperage it wants. And as you can see, so the charge is now sitting on 14.8 volts, and it's still monitoring what the battery's doing. So if this current, for example, went out of control, it would the charger would shut down. So we're going into the bulk charging phase now. It's not drawing a huge amount of current because it is really not very far discharged. Settling back down to 6 amps now. Going into that next stage of absorption. And it seems to me now that the battery charger is detecting that the battery is quite healthy. It's about to go into maintenance or boost mode. It'll be interesting to see what it does. The battery is quite stable at 13.8 volts, holding that, maybe just down to 13.7 volts there. So the charger is just seeing what the battery's doing. It should, with no load, be holding that voltage quite steadily. And now that's settled into a nice maintenance cycle there. All things considered, it seems to me like this little battery is probably okay. Might have had a bit of a hard life. And in particular in small cars, sometimes they do have a hard life because they are being expected particularly to run electric windows and air conditioning systems. And it might just have needed a little bit of tender loving care on a system like this. This is a day spa for a battery. Okay, so hopefully we won't need to spend money on a new battery. Cheers.